China.
China.
China. China.
China.
China.
China.
China.
China.
The satellite images were unmistakable. Deep in Shenzhen's industrial heartland, massive construction crews worked through the night, erecting what would become the most audacious challenge to American technological supremacy in decades. This wasn't just another factory rising from Chinese soil, it was Huawei's bold declaration that no sanction, no matter how severe, could stop their march towards semiconductor independence. What U.S. policymakers discovered through those grainy satellite photos sent shockwaves through Washington's corridors of power. For nearly 5 years, American officials had convinced themselves that cutting Huawei off from advanced chip technology would cripple the Chinese tech giant permanently. Instead, they were witnessing something that defied every expert prediction: the birth of a complete semiconductor ecosystem, built from scratch in record time, designed to shatter the very foundations of Western technological dominance. The scale of what Huawei had accomplished was breathtaking. By early 2025, the company had achieved something that semiconductor veterans deemed impossible just 3 years earlier. Their Ascend 910C artificial intelligence processors were rolling off production lines with a 40% yield rate, nearly double their performance from the previous year. This wasn't incremental progress, it was a technological quantum leap that put profitable mass production within immediate reach.
What we're witnessing defies every conventional wisdom about semiconductor development. Huawei has compressed what should have been 15 years of painstaking development into less than 4. The implications for global technology balance are absolutely staggering.
The numbers backing up his assessment were remarkable. Huawei was preparing to manufacture 100,000 AI processor units within 12 months, each one a testament to China's growing ability to compete with the world's most advanced chipmakers. These weren't simple processors either. Performance benchmarks showed Huawei's latest Cloud Matrix 384 system, integrating 384 Ascend processors through cutting-edge optical technology, outpaced comparable NVIDIA systems by 67%, while offering triple the memory capacity. But Huawei's masterstroke wasn't just technological, it was strategic. The company had constructed an intricate network of seemingly independent firms that worked together like pieces of a carefully orchestrated puzzle. SiCarrier emerged to produce deep ultraviolet lithography equipment. SiCarrier specialized in memory chip manufacturing. Shenzhen Penson Technology focused on logic processors. On paper, these were separate companies. In reality, they formed an integrated supply chain designed to circumvent every American restriction. The arrangement was brilliant in its simplicity. Personnel moved freely between facilities. Technology flowed seamlessly from one company to another. Government funding reached each firm through different channels, making the connections harder to trace. It was a shell game played on an industrial scale, with each move calculated to stay one step ahead of American sanctions.
The Americans thought they could strangle our technological development with export controls.
A senior Huawei engineer revealed during a rare industry conference appearance in Shanghai.
Instead, they forced us to innovate beyond our wildest dreams. Every restriction became motivation. Every closed door pushed us to build something better ourselves.
The human dimension of this technological race was equally impressive. Since 2020, Huawei had recruited over 12,000 engineers specifically for semiconductor development, many lured back from Silicon Valley with patriotic appeals and compensation packages that rivaled anything offered by American tech giants. Chinese universities had tripled their semiconductor engineering enrollments. An entire generation of scientists who might have spent their careers abroad were returning home to build something unprecedented. Zhang Wei, a 34-year-old chip designer who left Google to join Huawei's semiconductor division, captured the prevailing mood perfectly.
Every processor we successfully produce represents more than technical achievement, he explained. It's proof that Chinese innovation can compete with anyone, anywhere. We're not just building chips, we're building technological sovereignty.
The scope of China's commitment became even clearer when additional satellite imagery revealed another massive project near Shanghai. Huawei was investing $1.66 billion in a research and development center spanning an area equivalent to 224 football fields. With capacity for 35,000 personnel, it would become one of the largest technology research facilities on Earth. This wasn't about catching up anymore. Huawei was positioning itself to leapfrog the competition entirely. The company's investment arm, Hubble, had poured money into over 60 semiconductor companies since 2019, methodically building every link in the supply chain. From carbon nanotube wafer specialists to packaging material producers, each investment represented another brick in the wall of technological self-sufficiency.
The people fundamentally misunderstand the psychology driving this transformation, explained Professor Liu Wei from Tsinghua University's School of Integrated Circuits. For decades, China accepted its role as the world's assembly line, putting together products designed elsewhere. American sanctions changed everything. They transformed semiconductor independence from an economic goal into a matter of national pride and survival.
The ripple effects were already reshaping China's entire technology sector. SiCarrier, the country's largest chip manufacturer, worked hand-in-hand with Huawei to refine production processes. SiMEE provided critical engineering support. Dozens of smaller firms contributed specialized components and materials. What emerged was a coordinated industrial mobilization, unlike anything seen since World War II. Yet, formidable challenges remained. The U.S. government, recognizing the existential threat to American technological leadership, had already added SiCarrier and SiCarrier to its entity list. This move blocked American companies from supplying any technology to these firms, forcing them to source everything from Europe, Japan, or develop domestic alternatives. More fundamentally, semiconductor manufacturing remained one of the most complex industrial processes ever devised. A single advanced chip required hundreds of precise steps, each demanding extraordinary accuracy. Industry veterans joked that only 3 things in the universe required nanometer-level precision: semiconductor manufacturing, DNA replication, and the ego of a semiconductor CEO. Huawei's relative inexperience showed in subtle but important ways. Their chips, while functional and competitive, consumed more power than comparable Western designs. Software optimization lagged behind hardware development. The ecosystem, impressive as it was, still contained gaps that would take years to fill completely. But perhaps the most significant impact wasn't technological at all. It was psychological. For decades, the global semiconductor industry had operated on the fundamental assumption that no single country could build a complete supply chain independently. The costs were too enormous, the expertise too specialized, the equipment too complex. Huawei was systematically proving that assumption wrong, and in doing so, reshaping how nations thought about technological sovereignty.
We're entering an entirely new era of global technology competition, predicted Dr. Sarah Martinez, a supply chain expert who advised Fortune 500 companies on semiconductor strategy. The old model of peaceful global specialization is breaking down rapidly. Countries are realizing that in critical technologies, independence matters far more than economic efficiency.
The evidence mounted daily. European nations were launching ambitious chip initiatives. India was courting semiconductor manufacturers with massive subsidies. Even smaller countries were questioning whether they needed domestic chip production capabilities. The age of technological interdependence was giving way to an era of strategic autonomy, with Huawei leading the charge toward a fundamentally different world order. The transformation didn't happen overnight, but by late 2024, the signs were impossible to ignore. Inside Huawei's sprawling Dongguan campus, engineers worked around the clock testing something that shouldn't have existed: artificial intelligence processors that could rival anything coming out of Silicon Valley. The breakthrough came not through a single eureka moment, but through thousands of incremental improvements, each one chipping away at America's technological advantage. The real shock came when independent benchmarking revealed the truth about Huawei's latest achievements. Their Ascend 910C processors weren't just catching up to Western competitors. In specific applications, they were pulling ahead. Training large language models, the foundation of artificial intelligence systems, required massive computational power. Huawei's chips delivered that power while consuming 30% less energy than comparable American designs.
The efficiency gains are genuinely remarkable. When you're running thousands of processors simultaneously, that energy difference translates into millions of dollars in operational savings annually. Huawei isn't just competing on performance anymore, they're competing on total cost of ownership.
The implications rippled far beyond corporate balance sheets. Major Chinese technology companies had spent years depending on expensive American processors for their artificial intelligence operations. Baidu, Alibaba, and Tencent collectively purchased over $2 billion worth of NVIDIA chips annually. Now, domestic alternatives offered comparable performance at significantly lower prices, with the added benefit of guaranteed long-term availability regardless of shifting political winds. The psychological impact proved even more significant than the economic benefits. For the first time since semiconductors became the backbone of modern technology, Chinese companies could build artificial intelligence systems without depending on American approval. The sense of liberation was palpable in boardrooms across Beijing and Shenzhen, where executives had grown tired of planning around the constant threat of sanctions.
We spent 5 years living in fear that American politicians would cut off our chip supply. Now we're planning data centers with domestic processors that outperform anything we could import. The tables have turned completely.
The speed of adoption surprised even Huawei's leadership. Internal projections had assumed a gradual transition as Chinese companies slowly gained confidence in domestic alternatives. Instead, demand exploded almost overnight. By March 2025, Huawei's order backlog stretched 18 months, forcing the company to prioritize strategic customers while frantically expanding production capacity.
China.
The world changed forever on August 21, 2023, when 2 prototype satellites silently slipped into orbit above Earth, carrying technology that could render every existing internet service obsolete. These weren't ordinary satellites. They were the first pieces of Huawei's audacious plan to deploy 10,000 satellites that would blanket the planet in 6G connectivity, promising speeds that would make today's fastest internet look like dial-up. Elon Musk's Starlink just received a massive wake-up call from an unexpected competitor. Huawei has announced plans to deploy a staggering 10,000 satellites for a cutting-edge 6G network, making Starlink's current constellation of over 4,000 satellites look modest in comparison. This bold move represents a monumental leap in technology and ambition that could fundamentally reshape the global telecommunications landscape. Huawei's satellite initiative represents more than just another internet service provider entering the market. The Chinese tech giant envisions a world where connectivity knows no bounds, where every corner of the globe, from the densest urban jungles to the most remote wilderness, enjoys seamless high-speed internet. This vision is no longer a distant dream, but an impending reality that directly challenges established players like SpaceX's Starlink. The deployment of 10,000 satellites will create a dense web of communication nodes orbiting Earth, ensuring comprehensive coverage and ultra-low latency. This network promises to be a critical feature for next-generation applications like autonomous vehicles, real-time holographic communications, and advanced IoT ecosystems. The scale of this project dwarfs current satellite internet services and positions Huawei as a formidable competitor in the space-based telecommunications arena. Huawei's strategy involves a sophisticated dual-orbit approach that sets it apart from traditional satellite constellations. The company plans to deploy approximately 8,000 satellites in low Earth orbit, positioned at altitudes ranging from 500 to 2,000 kilometers above Earth. These satellites are specifically engineered to provide low-latency, high-speed internet access essential for real-time applications such as autonomous driving and telemedicine. The remaining 2,000 satellites are planned for geostationary orbit, stationed around 35,800 kilometers above the equator. This positioning offers stable and continuous coverage over specific regions, creating a comprehensive global coverage system while optimizing performance based on geographical needs. This dual-orbit approach ensures that Huawei's network can deliver both the speed advantages of LEO satellites and the stability benefits of GEO satellites. One of the standout features of Huawei's satellites is their innovative propulsion systems utilizing electric propulsion technology. These satellites can maintain precise orbits with minimal fuel consumption, significantly extending their operational lifespan compared to traditional satellite systems. Additionally, advancements in solar panel efficiency and battery storage allow the satellites to operate efficiently even during extended periods without direct sunlight, addressing a common challenge in space environments. Huawei's satellites incorporate state-of-the-art communication technologies, including terahertz frequency bands and advanced beamforming techniques. Terahertz frequencies offer vast bandwidth capabilities, enabling data transfer rates that far exceed those of current 5G networks. Beamforming technology allows the satellites to focus their signals precisely where needed, enhancing connection quality and reducing interference significantly. The integration of AI-driven network management systems ensures optimal resource allocation and adaptive responses to fluctuating demand patterns. This intelligent approach to network management represents a significant advancement over current satellite internet services, potentially delivering unprecedented levels of service quality and reliability. Security remains a paramount concern in any large-scale satellite deployment, and Huawei addresses this through robust encryption protocols and quantum-resistant algorithms embedded within the satellite architecture. These measures protect against cyber threats and ensure the integrity of transmitted data, a critical factor given the sensitive nature of information handled by modern communication networks. When comparing Huawei's projected capabilities with Starlink's current offerings, the differences are substantial. Starlink currently operates over 4,000 satellites in low Earth orbit and has established a proven track record of providing broadband internet to underserved areas worldwide. However, Huawei's system promises enhancements in speed, reliability, and scalability that could potentially render existing solutions obsolete. Starlink's current network delivers download speeds ranging from 25 to 220 Mbps with latency between 20 to 40 milliseconds in most locations. Huawei's 6G satellite network aims to deliver significantly higher speeds and lower latency through its advanced technology stack and denser satellite constellation. The terahertz frequency bands alone could provide bandwidth capabilities that dwarf current 5G and satellite internet speeds. The reliability factor also plays a crucial role in this comparison. Starlink's single-orbit approach relies primarily on LEO satellites, while Huawei's dual-orbit strategy provides redundancy and improved coverage consistency. This approach could result in more stable connections and better service availability, particularly in challenging geographical locations. The implications of Huawei's project extend far beyond technological advancement, touching upon geopolitical dynamics and economic shifts. As nations increasingly view connectivity as a cornerstone of national security and economic growth, Huawei's satellite network positions China at the forefront of a new digital frontier. This strategic move could redefine international relations, influence trade policies, and alter the balance of power in the tech industry. The US-China tech competition intensifies with this announcement, as satellite internet becomes another battleground for technological supremacy. Western governments may implement restrictions on Huawei's satellite services due to national security concerns, similar to the restrictions placed on the company's terrestrial telecommunications equipment in recent years. For consumers, this development could bring significant benefits, including better global internet access in remote areas and competition driving prices down. The advanced applications enabled by 6G technology could revolutionize autonomous vehicles, IoT systems, and augmented reality experiences. Improved disaster communication capabilities could also enhance emergency response systems worldwide. However, realistic timeline expectations must be considered. While Starlink already provides operational services to millions of customers, Huawei's network remains in the planning and early development stages. The company faces significant technical challenges, including space debris concerns with 10,000-plus satellites, massive launch logistics and costs, and extensive ground station infrastructure requirements. Regulatory approvals across different countries present another major hurdle. Many Western nations may refuse to grant Huawei the necessary licenses to operate satellite internet services, limiting the network's global reach and commercial viability. The funding requirements for such massive deployment are enormous, potentially requiring tens of billions of dollars in investment. The commercial viability of operating 10,000 satellites while competing against established players like Starlink, Amazon's Project Kuiper, and OneWeb remains questionable. SpaceX is unlikely to remain passive in the face of this challenge. The company continues to launch Starlink satellites regularly and has plans to deploy thousands more. Elon Musk's track record of rapid innovation and cost reduction could help Starlink maintain its competitive edge through technological improvements and pricing strategies. Industry experts remain divided on the feasibility of Huawei's ambitious timeline and technical claims. While the technology appears promising on paper, the practical challenges of deploying and maintaining 10,000 satellites are unprecedented. Most realistic scenarios suggest a partial deployment with regional focus rather than immediate global coverage. The question of whether this represents the end of Starlink requires a nuanced answer. Rather than eliminating Starlink, Huawei's entry into the satellite internet market will likely intensify competition, leading to better services and potentially lower prices for consumers. Multiple players will probably coexist in different markets, with geopolitical factors heavily influencing regional adoption patterns. This development signals a new era in satellite internet services where technological advancement and geopolitical considerations intersect. While Huawei's promises are impressive, they remain unproven, and the company faces significant technical, financial, and regulatory challenges. The ultimate beneficiaries of this competition will be consumers worldwide, who can expect improved connectivity options regardless of which company ultimately succeeds in their ambitious plans. The satellite internet market is rapidly evolving beyond a simple two-horse race between Huawei and Starlink. Amazon's Project Kuiper plans to deploy 3,236 satellites by 2029, while OneWeb continues expanding its constellation with backing from the UK government and Party Global. These developments create a multifaceted competitive landscape where innovation accelerates across all players. Huawei's announcement also highlights the growing importance of space-based infrastructure in national digital strategies. Countries worldwide are recognizing that satellite internet capabilities represent critical national assets, influencing everything from economic development to military communications. This realization is driving increased government investment and support for domestic satellite programs. The timeline for Huawei's deployment remains the most significant question mark. Historical precedents suggest that satellite constellation deployments typically take longer and cost more than initial projections. Starlink itself took nearly 5 years to reach its current operational capacity, despite SpaceX's proven launch capabilities and manufacturing efficiency. Environmental considerations add another layer of complexity to Huawei's plans. The deployment of 10,000 additional satellites raises concerns about space debris, orbital congestion, and the long-term sustainability of low Earth orbit operations. International space agencies are increasingly focused on these issues, potentially leading to stricter regulations that could impact deployment timelines and operational procedures for all satellite internet providers.
China.
20% yield. That's the harsh reality facing China's most advanced semiconductor production lines right now. While the world debates whether China can truly compete in cutting-edge chip manufacturing, a stunning revelation has emerged from behind the closed doors of SMIC's fabrication facilities. The company that shocked the global tech industry by producing 7-nanometer chips for Huawei's Mate 60 Pro smartphone is now pushing into even more ambitious territory, attempting to manufacture 5-nanometer semiconductors without access to the West's most critical chip-making tools. The stakes couldn't be higher. Every smartphone in your pocket, every artificial intelligence system powering the future, and every advanced military system depends on these tiny silicon wafers. And right now, in facilities across China, engineers are attempting what many industry experts deemed impossible just 2 years ago. They're trying to produce chips that match the world's best, using equipment that's fundamentally inferior to what their competitors possess. The collaboration between Huawei, the global leader in telecommunications equipment, and SMIC, China's premier semiconductor manufacturer, represents more than just a technological achievement. It demonstrates China's emergence from a position of playing catch-up to leading the charge in next-generation wireless communication technology. This breakthrough didn't emerge from traditional tech powerhouses in Silicon Valley or Seoul, but from China, a nation often underestimated in advanced semiconductor manufacturing. Huawei's journey into 6G technology began long before the world fully embraced 5G networks. Recognizing the transformative potential of next-generation networks, the company invested heavily in research and development, assembling a team of world-class engineers and scientists. Their ambitious goal was to create a chipset capable of supporting unprecedented data speeds, ultra-low latency, and massive device connectivity. The defining hallmarks of 6G technology. SMIC's role in this achievement cannot be overstated. For years, the company had been striving to close the gap with industry leaders like TSMC and Samsung. The 5-nanometer process node, once considered the exclusive domain of these giants, became a reality for SMIC through years of meticulous research and development backed by billions of dollars in investment. This breakthrough allowed them to produce chips with unparalleled efficiency and performance, setting the stage for Huawei's 6G ambitions. The partnership between these two Chinese technology titans proved symbiotic. Huawei provided the architectural blueprint for the 6G chip, leveraging its expertise in wireless communication technologies, while SMIC delivered the precision engineering needed to bring this design to life. Together, they overcame significant technical challenges including thermal management issues, power consumption optimization, and signal integrity problems that had previously stymied efforts to scale down chip dimensions while maintaining performance. What makes this achievement even more remarkable is the context in which it occurred. Amid escalating trade tensions and export restrictions targeting Chinese tech firms, Huawei and SMIC faced immense pressure to innovate independently. Denied access to critical tools and materials from Western suppliers, they turned inward, fostering domestic supply chains and developing homegrown solutions. This resilience underscores their technical prowess and highlights the broader narrative of self-reliance driving China's tech ecosystem. The 5-nanometer manufacturing process represents one of the most advanced semiconductor fabrication technologies available today. At this scale, transistors are smaller than many viruses, allowing for dramatically improved performance and energy efficiency. Previously, only TSMC and Samsung possessed the capability to manufacture at this level, making SMIC's achievement a significant milestone in global semiconductor competition. Huawei's 6G chip delivers ultra-high data throughput that dwarfs current capabilities. While 5G networks boast peak speeds of up to 10 gigabits per second, this new 6G chipset is engineered to deliver speeds exceeding 1 terabit per second. This exponential improvement means downloading an entire library of movies would take less than a second, fundamentally transforming how we interact with digital content. Beyond raw speed, the chip achieves ultra-low latency that enables real-time applications previously impossible. Remote surgeries can be performed with zero lag, autonomous vehicles can communicate seamlessly with infrastructure, and smart cities can operate with clockwork precision. The chipset also supports massive device connectivity, allowing unprecedented numbers of Internet of Things devices to connect simultaneously without network congestion. The healthcare industry stands to be revolutionized by this technology. Zero-lag remote surgeries become feasible when surgeons can manipulate robotic instruments in real time across continents. Real-time diagnostics powered by 6G connectivity will enable instant analysis of medical data, potentially saving countless lives through faster intervention. Transportation systems will undergo fundamental changes as autonomous vehicles gain the ability to communicate seamlessly with each other and traffic infrastructure. This ultra-fast, ultra-reliable connectivity enables split-second decision-making that could virtually eliminate traffic accidents and optimize traffic flow in ways never before possible. The entertainment industry faces a complete paradigm shift. Instant content delivery means no more buffering, while immersive experiences through augmented and virtual reality become truly seamless. 6G technology enables real-time rendering of complex virtual environments, making current streaming limitations obsolete. Smart cities will operate with clockwork precision as 6G networks connect millions of sensors, traffic lights, utility systems, and public services in real time. This connectivity enables predictive maintenance, optimized resource allocation, and responsive public safety systems that can react instantly to changing conditions. Manufacturing industries will benefit from real-time industrial Internet of Things applications. Factory equipment can communicate instantly, enabling predictive maintenance, quality control, and production optimization that responds to changing conditions in milliseconds rather than minutes or hours. This breakthrough directly challenges established tech giants including Apple, Qualcomm, and Samsung, who have traditionally dominated the high-end chip market. Huawei and SMIC's success disrupts traditional supply chains and creates new market dynamics where Chinese companies compete at the highest technological levels. The geopolitical implications extend far beyond technology. China's achievement demonstrates technological sovereignty and challenges the assumption that cutting-edge innovation requires Western technology and expertise. This shift impacts the global balance of power in technology development and could influence future trade policies and international cooperation agreements. Despite facing export restrictions and sanctions designed to limit their technological progress, Huawei and SMIC have proven their domestic innovation capabilities. Their success demonstrates that restrictions may have inadvertently accelerated China's push toward technological independence, potentially creating a more fragmented global technology landscape. Looking toward the future, 6G technology is expected to begin commercial deployment within the next 5 to 7 years. Infrastructure development will require massive investment in new base stations, fiber optic networks, and supporting technologies. The gradual rollout will likely begin in major cities before expanding to rural areas. Huawei and SMIC are now focused on scaling up production capabilities to meet anticipated global demand. Further technical improvements are already in development, including enhanced power efficiency and additional features that could cement their leadership position in 6G technology. Competitors including Qualcomm, Intel, and MediaTek are undoubtedly accelerating their own 6G development programs in response to this breakthrough. The next few years will see intense competition as companies race to bring competing 6G solutions to market. This achievement represents a watershed moment in technological history, demonstrating how collaboration, determination, and ingenuity can overcome seemingly insurmountable obstacles. The success of Huawei and SMIC proves that innovation knows no boundaries and that technological leadership can emerge from unexpected sources. For consumers worldwide, 6G technology will fundamentally transform daily life within the next decade. From instant access to vast digital libraries to seamless augmented reality experiences, the applications enabled by terabit per second speeds will create possibilities we can barely imagine today. The breakthrough achieved by Huawei and SMIC brings this transformative future significantly closer to reality.